This is section 4.1, trigonometric functions. You can pause at any point this video. If you feel that I'm rushing through certain parts, like I said, all you need to do is just pause. These are the objectives for this lesson. Students will be able to describe angles, use radian measure, compare between degree and radian measure. The last one is use angles to model and solve real-life problems. This is the vocabulary key concepts. You can read them. I'm going to define definition of a radian. 1 radian is a measure of a center angle theta that intercepts an arc S equal to the radius r of the circle. This is the definition. Let me give you an algebraic definition. Theta is equal to S over r, the ratio of the arc over the radius. Arc is a portion of the circumference of the circle. Let me give you this illustration so you can better understand this idea of 1 radian. So let's say that this is your radius, r. The distance, we'll call it r. And this is going to be your arc. If this radius and this distance of this arc are equal, this is what we call 1 radian. So the degree measurement of this angle in radians will be 1 radian. Moving on to the next slide. Determine the quadrant in which each angle lies, and I'm giving you -5 pi over 12. Let's review quadrants. This is from Algebra 1, 1, 2, 3, and 4. Also, degree measurements. This is your 0 degrees, also 360 degrees. We open the degrees, we count the degrees counterclockwise from 0, 90, 180, and so forth, all the way to 360. This is always the initial side, the 0 degrees. This is what we call a negative angle because of the negative sign. So what we're going to do is I'm going to show you this formula. This is how you're going to compute radians to degrees. This is a radian measure, and we're going to change it to degree measure. So all we need to do is take the radian measure, which is -5 pi over 12, and multiply times 180 over pi. That's what the formula is telling us to do. You can do that, and you end up with -75 degrees. If you open from your initial side -75 degrees, you're not going to go counterclockwise. You're going to go clockwise from the 0 degrees. So this will be -90 degrees, since it's less than -75 is less than -90. So you're still in quadrant 4. Part B, 13 pi over 9. Again, this is a positive angle. We change this 13 pi over 9 into degrees. So we use this formula, very similar to this. The process is very similar to this. 13 pi over 9 times 180 over pi, and you end up with 260 degrees. 260 degrees is between 180 and 270, so you know it's in quadrant 3. And this is another formula. This is to go backwards. If you want to go from degrees to radians, you can use this formula. So if you want to change this back to radians, multiply 260 times pi over 180, simplify the fraction, and you're going to end up with this. 3.5 is the second angle that you need to determine. Number 2, part A. You have to determine where this angle lies. First thing we're going to do is we're going to change this to degrees, and this is radians, 3.5 radians. If it was degrees, it would have the degree symbol here, but since it doesn't, it's not degrees. It would have that little symbol here that we use to represent degree measurement. So we change that to degrees using this formula, and we end up with 200.5 degrees. So this is in quadrant 3, since this number lies between 180 and 270. And the last one, you have negative 4.72. This is negative, so you know that you're going to have to go clockwise from 0. We change this to degrees, and we end up with negative 270.4. So if you travel from the initial side, I don't know if I highlighted initial side, but this is always your initial side, the positive side of the x-axis. So if you were to travel 270 degrees 0.4, excuse me, so we travel from here. This is 270, 0.4 is just a little bit more. So this is your angle. So this angle will be in quadrant 4. This is your initial side, which implies that this is your terminal side. Another word that you should know. Moving on to the next slide. And then also, I'm sorry, this is in quadrant 1. Excuse me. Technical difficulties there. So number 3, sketch each angle in standard position. You're gonna draw a negative 7 pi over 4 in this coordinate plane. The first thing that you want to do is change this to degrees, and you end up with negative 315 degrees. You can do that by using that formula I showed you earlier. And then at this point, you get your you have to sketch. So you know that you need to start at the initial side. Since it's negative, you're going to travel clockwise from the initial side. This is 90, this is 180, negative, this is negative 270, negative 315, somewhere over here. So this is negative 7 pi over 4. Now notice that if I was to sketch 45 degrees, this is positive. I would end up in the same location. And this is what we notice that negative 315 and 45 degrees have this same endpoint, same starting point, same endpoint. We just went about it a little bit different. But these two angles are coterminal because they have the same initial and terminal side. Another term that you need to know. Let's go to B. You have 4 radians. We're going to change this to degrees using that formula you saw on the previous slide. And you end up with 229.2 degrees. So if I was to sketch this angle, I know it's going to be in quadrant 3. This is just an approximation. A rough sketch. Looks about 180, 40 degrees more, somewhere around here. So this is angle with 4 radians. And let me show you this f squared. This is just for fun. Why is 1 radian approximately equal to that? If you're bored and you have nothing better to do, see if you can tell me why this is the case. Determine 2 coterminal angles in radian measure, 1 positive and 1 negative for each angle. So we start with 7 pi over 6. So what we're going to do is we're going to take 7 pi over 6 and we're just going to add 2 pi to it. 2 pi we know is 1 revolution, or 360 degrees, and that's how we end up with 19 pi over 6. Excuse me. Now this is a positive one, come up with a negative one. So instead of adding, now I'm going to take away 2 pi, and I end up with this. These 2 angles are coterminal to 7 pi over 6. 1 positive, 1 negative. Part B, coterminal angles to negative 10 pi over 3. Let's start out with the positive one. In this case, if I add 2 pi, I'm still going to end up with a negative angle, so that's why I need to add one more revolution, and that's how I end up with 2 pi over 3, or I'm adding not 2 pi, I'm adding 4 pi, and that's how I end up with 2 pi over 3. To come up with a negative, I don't have to worry about that one, just take away negative 2 pi, and then I end up with this. So all these angles have the same initial and terminal side. Different values, but same initial and terminal side. It says find the complement and supplement of the angle, if possible. Remember from geometry. This is what it means to be complementary, alpha and beta, or two angles that add up to 90. We can also use radian, pi over 2. Since we have radians, we're going to have to work with radians. And complementary, this is complementary and this is supplementary when alpha and beta add up to 180. And you know that alpha and beta, or the angles, have to be positive angles. So what we can do is change this to degrees. Once you do that, you're going to realize that it's not possible. We cannot have a complement, and again, if you change it to degrees, you know that this is 135. So I cannot come up with another angle that adds up to, that I added to 3 pi over 4, that gives me pi over 2 or 90 degrees. So that's why this is not possible. Supplement, we can. What we need to do is from pi, or 180, we take away this angle, 135 or 3 pi over 4, and that's how I end up with pi over 4. If you were to add pi over 4 and 3 pi over 4, you know that they add up to pi. B, this is also in radians. And complement not possible. If you don't see it, again, change this to degrees, and you know that you end up with this. 114.6, that's why it's not possible to have a complement to 2 radians. Supplement it is pi minus 2. You can live like this, or you can give me this approximation. Number 6, this is pretty straightforward. This is the formula you need to use. Angle in radians is given by S over R. We saw this definition earlier. S represents the arc, R is the radius, and theta is the center angle. In this case, it's going to be in radians. So I apply this formula, and I end up with 31 over 12 radians, or you can change that to an improper, and that's how we end up with this. B, you have the radius, 75 feet. Well, let me highlight this again. Again, you probably know this, but just to make sure, this is the radius, the distance from here to here, and the distance from here to here is the S, which is the arc. Anyway, B, so the radius, the arc, you use the formula, and you end up with this. So make sure that you tell me that it's in radians, so then this should be the final answer. Theta is equal to negative 4 over 5 radians, because it's opening clockwise from the, okay, negative 4/5 radians. Next one. This is the last one. It has 2 parts. This is a word problem. This is says the circular blade on a saw has a diameter of 7.25 inches and rotates at 4,800 revolutions per minute. Part A says find the angular speed of the blade in radians per second. What does it mean to what does angular speed mean? This is like a definition that will help you understand this problem a little bit better. So the first thing that we're going to do is choose the formula, which is right there. Notice that they want the answer in revolutions per second, and this is in revolutions per minute. So what we need to do is we need to change this to revolutions per second, and this is how you can do this. Revolutions, 4,800 revolutions per minute. I want this to be seconds, so I use this unit analysis. 1 minute is equal to 60 seconds. If you place it this way as a ratio, these units cancel out. 48 revolutions, and then per second. Simplify the fraction, and that's how you end up with this. So to find the angular speed, all I need to do is I'm going to take this information, 80 revolutions per second. I know that 1 revolution in radians is 2 pi. So all I need to do is take this number and multiply it times 2 pi, and I end up with my angular speed. Part B, and this is the last part, we're done after this. It says find the linear speed of the saw teeth in feet per second as they contact the wood being cut. Now notice that in the problem, well, here, let me give you what linear speed means. Measures how fast a particle moves. This is the formula that you're using for linear speed. Arc length over time, which is S over T, or the radius of whatever it is, whatever the radius is, times beta over time. But notice that this represents the angular speed from part A. So all we need to do is take part A, multiply times the radius. Since they want the radius in feet for feet per second, and in the problem they gave you inches, we're going to have to change that. So radius in feet, we take the inches, use unit analysis. We write a ratio 1 foot over 12 inches. The units go away, and we end up with this many feet as the radius of the blade. And notice in the problem they also give you the diameter, so you have to divide that by 2. 7.25 divided by 2, and that's how we end up with this. So I take this information, which is the radius, and I'm going to multiply it times part A, the answer to part A, and then I should be done with the problem. Linear speed is equal to this number times part A, 160 pi, and this is my final answer. This concludes the section, the first section, 4.1, trigonometric functions.